In this lesson, we're going to talk about arithmetic sequences. First, we're going to talk about some definitions and the notation. That's really the most challenging part of this, is understanding the notation. Then we're going to talk about how to identify arithmetic sequences, and then we're going to take a look at recursive formulas. Let's begin. First, a little bit of definition and notation, but let's look at this through an example. Marco is building towers out of dominoes. He uses a pattern to determine the number of dominoes to use at each level, as shown below. Level 1 is 1 domino, level 2 is 2 dominoes, level 3 is 3 dominoes, and level 4 is, well, we don't have level 4, but we can predict that level 4 is 4 dominoes. The number of dominoes at each level forms a sequence or a pattern of numbers. A sequence can be any pattern of numbers. This one happens to be an arithmetic sequence, which we'll talk more about what that means in a minute. Each number in the sequence is called a term. The nth term in the sequence can be written either using subscript notation or function notation. This is the first term, this is the second term, this is the third term, and this is the fourth term. Here's what subscript notation looks like. It's A sub n. That's how we read that, A sub n. A sub n is the term, and n is the term number. And we'll take a look at what that means here in a minute. Function notation is, you probably are familiar with this, f of n. F of n is the term, and n is the term number. In the domino example, the first 3 terms in the sequence are, so what this means is it's asking me for the first term. What is the first term? Well, the first term was 1, because there was 1 domino. The second term was 2, because there were 2 dominoes. And the third term was 3. That's what that means. What's the third term? What's the second term? What's the first term? In function notation, this means what's the fourth term? And it was 4, we predicted. You'll notice that each term was going up by 1. That makes it an arithmetic sequence. An arithmetic sequence is a sequence where the difference between consecutive terms is constant. Now there's another word there that you might not be familiar with. Consecutive means one after the other. So terms that are next to each other will have the same difference between them. This constant difference between the terms is called the common difference. Let's identify some arithmetic sequences. So first of all, is it arithmetic? Does it have a common difference? This first example here, it goes 3, 5, 7, 9, 11, 13. It appears to be going up by 2, so this is an arithmetic sequence because the common difference is 2. In this sequence, we're going down by 8, and then down by 8, and then down by 8. So that is also arithmetic, and the common difference is 8. It's going down by 8. Here, it's going up by 3, and then 6, and then 12, and then 14. There is definitely a pattern there, but it is not an arithmetic sequence, so it does not have a common difference. It's not applicable. This one is going up by 5, and then down by 5, and then up by 5, and again, there's a pattern, but it's not an arithmetic one because it's not the same difference every time. It's not going up by 5 all the time or going down by 5. And here we have another sequence. It's going down by 4, going down by 4, going down by 4. So yes, and the common difference is 4. One of the ways to represent an arithmetic sequence is by using a recursive formula. A recursive formula relies on the previous term to find the nth term. That prefix re means we're looking back. We're redoing it. We're looking back. We're going backwards in the formula. And so you always have to have the previous term. So in order to find the 63rd term, you need the 62nd term. In order to find the 10th term, you need to find the 9th term first. Recursive formulas have two different looks depending on whether we're talking about subscript notation or function notation. So in a subscript notation, we're looking at, this is asking us to find the nth term. So the 5th term, the 6th term, 7th term. This notation means the previous term. So for example, if I was trying to find the 10th term, then this would be asking me for the 10 minus 1, which is the 9th term. But really, if you just remember that that a sub n minus 1 means the previous term, the one that came before it, then you're good to go. And then the d is the common difference. What is my pattern? Is it going up by 5s? Is it going up by 2s? Is it going down by 3s? That's what you're going to add to the previous term. Same thing here. This is going to be the previous term. And this is going to be the common difference. The notation is kind of funky, but it's not really that hard to understand. It's what you guys just did when you were figuring out that table, is we were figuring out the pattern, and then we would use it to figure out the next term in the sequence. Let's take a look at what these recursive formulas look like in practice. In a recursive formula, they're always going to give you the first term or some term. Because if they don't give you one term, you're not going to be able to figure out the rest of the sequence with a recursive formula. So this is telling me that the first term is 11. And I have to find the first 5 terms of the sequence. It really helps me, at least, to write 1, 2, 3, 4, 5. Because a lot of times students will forget that this is the first term. They'll jump right to the second term and call that the first term, but they give you the first term. So you don't really have to find it. It's already given to you. And then this is my recursive formula. Remember, this means the previous term plus 6. So if I want to find a sub 2, I'm going to add the previous term, which was 11, plus 6. So it's 17. If I want to find a sub 3, I'm going to do a sub 2, which was 17, plus 6, which is 23. If I want to find a sub 4, I'm going to do the previous term, which is a sub 3, plus 6. In this case, that's 23, plus 6. And this is probably old hat for you guys. You can probably add these numbers without doing the formula like that. If I add 7 to this, I get 36. Oh, I'm adding 6 to this. I get 35. Careful. You can find numbers in a sequence. It's the notation that is a little bit tricky to understand. So just remember, this is the first term, and then this is add whatever the first term is plus 6. Previous term plus 6. Previous term plus 6. You'll notice that with a recursive formula, like I said before, you always have to know, in order to find the 5th term, I have to know the 4th term. If I asked you guys using the recursive formula to find the 30th term, you would have to find all 1 through 29 terms first before you could tell me what the 30th term is. In a future video, we'll look at a formula called an explicit formula that will give you that 30th term without having to know the 1 through 29 first. Sounds good, doesn't it? One more example to look at. The recursive formula for a sequence is f of n equals f of n minus 1 plus 4, where f of 1 equals 2. So this is in function notation instead of subscript notation, but it's still telling us that the first term is 2. And we're basically going to add 4 to each term to find the next one. So the first 4 terms are 2, that's my first one, given to me. The second one I'm going to add 4 is 6. Third one is 10. And then the fourth one is 14. Create a graph and describe the relationship. So I'm going to use, this is going to be the term number, and then this is going to be the value of that term. So term number 1 is 2, term number 2 is 6, term number 3 is 10, and term number 4 is 14. Can you describe the relationship here? Well, for every increase in term, we are adding 4. Do you see that? For every increase in term, we are adding 4. For every increase in term number, I am adding 4. That's how I would describe the relationship. And what is the domain? Well, this is a discrete function, which means it doesn't make sense to have 1.5 terms. So I'm not going to connect the dots here. Doesn't make sense to have 2.5 terms or 3.1 terms. I'm not going to connect the dots. So it's a discrete function, and the domain is all reals, all integers, all positive integers. Just clarifying, it's not all reals because it's not the decimals. It's not all positive numbers, again, because it's not the decimals. It's all integer, positive integers. My mouse is not as fast. All positive. There we go. Positive integers. Another way of saying that is all whole numbers. All whole numbers. All right, so hopefully you now know a little bit about arithmetic sequences, and we will talk in the next video about explicit formulas.